Okay. In network point of view, layered architecture playing an important role. Okay, whatever may be the protocol suite, TCP, IP, or X.25 or frame relay, whatever may be the protocol suite, that is based on a specific architecture. Okay, a specific layering approach. Okay, so first of all, you have to understand why this particular computer network components are arranged in a layered manner. Okay, so it's a protocol suite, and each and every layer we have set of protocols. Okay, so that whatever we are learning in the computer network, you can just compare with the real time scenario. Okay, let's see a very simple scenario here. For example, we need to travel from one place to another place, okay, through the transport mode, airways. Okay, so what are the things you have to perform? First of all, as a end user, you have to buy the ticket. Okay, see, the first, it will start like this. Normally, whenever we talk about the layered approach, the process or action starts from this, okay, in this direction, top down direction. That's why you are learning computer network in the top down approach. Okay, so it's start like this. First of all, as a end user, the user, not whatever the thing we are doing, computer network or operating system, whatever it may be, ultimate users are human. Okay, so the user can interact directly with this, the first layer. Okay, first of all, we have to purchase the ticket. You have to go to the office, you have to purchase the ticket, or otherwise through online mode you have to purchase the ticket. Okay, so after that, once after purchasing the ticket, then you can, let's say, the day of travel, and whenever you perform a travel, first of all, the checking is for your luggages and packages. Okay, so the second task is that you have to check out your packages. Okay, or luggages, and another the next step here is you have to be loaded in the gate. Okay, so once it is airways or airplane loaded with the people, loaded with a human, then it runs on the runway. Okay, so runway, after that it enter into the actual routing. In airways, there are different routings are available. Either it passes through some country, or depends upon the routing. The Airbus travels from one location to another location, that is departure location to the destination location, starting location to the destination location. Okay, it passes through, actually this is actually the transport. Okay, this is the transport or travel. Okay, so the transport occurs from one location to another location. Even in networking, the packet should travel from one location to another location, then only we can achieve the actual transmission of data, the transport playing a role. So the Airbus travel from one location to another location based on the predefined route. Okay, not like selecting the route based on the need, not like that. Okay, based on the predefined route, I travel from the source to the destination. Okay, after reaching the destination, again it comes to the runway. Okay, and it will be landed, and after that the gate will be opened and the people will be unloaded. Okay, and the people can climb their own luggages, and then the any complaint about the ticket to be handled. Okay, so this is what the simple normal transport. If you take any type of transport, definitely there is a process like this. Okay, each and every step here is an independent component. Okay, I think in computer science point of view, we have the concept called modular approach of developing the program. Modular approach, computer programming point of view, we have the approach called modular approach. Okay, and in the data structure point of view, we have the method of writing the program that is known as divide and conquer approach. Divide and conquer. Okay, so what are these two approaches, modular approach or divide and conquer approach? What it means actually, if you have the complex program or complex thing, okay, complex problem, instead of solving the problem or instead of facing the problem directly, what we can do here is we can divide the problem into small subcomponents. Okay, and we can solve individual subcomponents first. Okay, after solving, because that might be easy. Okay, an individual programmer can also do that. Okay, an individual subcomponent to be solved, completed, and then after that, anyhow individual subcomponent cannot be work as a standalone component. Okay, and it should work together. After developing the individual subcomponent, then we can connect all together, we can integrate together to design the complete application. Okay, so that is what the divide and conquer approach means, or modular approach means. Okay, so computer network is also, there are so many things to be happen. Okay, whenever we transmit the data to be packed perfectly, and then it should be injected onto the NIC card, and from your laptop or from your host to the destination, the packet should travel. Okay, so without any disturbance, and then after reaching the destination, again the packet to be unpacked and then given to the application. So it's a complex thing, so many components are involved. Okay, so instead of developing the entire thing as a whole, we can apply a modular approach. We can divide each and every subcomponent, and we can concentrate on each and every subcomponent individually or independently, and then we can integrate together. Okay, this is what the idea. Okay, this is what the idea behind the computer network protocol suite. Okay, computer network means it's nothing but a protocol suite, whatever may be the network, telecommunication network or internet or high-speed network or any type of network. If you take any type of network, the network is based on the protocol suite, specific protocol suite. Okay, so the idea behind the protocol suite is a layered approach or modularization or divide and conquer approach. Okay, so this ticket purchase can be the separate service, one specific service. Okay, then luggage, checking the luggage, one specific service. Okay, all these elements, individual elements, are made up of a set of services. Okay, this layer alone is defined by a set of service. Okay, then ticket purchase, what we have to do? First of all, you have to tell your destination, and you have to check the availability, and you have to verify the airways, whether the airways is available in that location or not, and then you have to pay the money. So there are set of services are available. Okay, each and every service to be well defined. Okay, in this particular layer. Okay, that is pertaining to this layer alone. So whenever you define the service for ticket purchasing, you need not worry about how aeroplane or airways travel from one end to another end, what should be the routing and what should be the in between things. You need not worry about all those things. Okay, so whenever we talk about this ticket purchase, this particular protocol, this particular layer, not protocol, this is a layer. Okay, this is a first layer. Okay, and this is a, let me write it out like this. This is layer 1. Okay, when you start from bottom up, layer 1, layer 2, and we have layer 3. Okay, and we have layer 4 and layer 5. We have 5 different layers. Okay, each and every layer is a well defined independent task. Okay, so if you take a purchase of a ticket, that alone it requires some services. Okay, net banking or enabling the payment, selecting the airways. Okay, maybe so many options. You might be interested to travel from Chennai to Hyderabad. Okay, there are so many options are available. You can use either SpiceJet or Jet Airways, anything. So all those options to be selected, any best one to be selected, and then you have to pay the net banking application. All these are known as microservices, micro level element. Okay, so those are known as services. So what is the purpose of each layer? Each layer provides services. Okay, so how to define those services? By means of a protocol. Okay, each and every service is to be defined by means of a rule set called protocol. Okay, so this is what the idea. And whenever we talk about the layered architecture, this is actually in computer network point of view, this is a sender and this is a receiver. Okay, but transmission can happen in both the ways. Here in this case, we are moving from one end to another end. Okay, one way transmission. But if we talk about computer network, it allows two-way communication, even telecommunication or data communication, whatever it may be. It allows to send the data and receive the data. Okay, it allows two-way communication. So both will be the end system. Okay, this is one end system and this is one end system. Okay, I can define it like this. This is not server is nothing but end system, or otherwise I used one notation called host. Okay, computer or sensor device, a PDA, any device capable of transmitting and receiving the data. Okay, so the receiver may be N system. So this entire thing runs on sender end system or one end of the communication, and this entire thing runs on another end of the communication. Okay, so these two are end system. What about this? This thing is an entire computer network infrastructure. It passes through existing network infrastructure, tier 1, tier 2, tier 3 service provider. Okay, so it made up of only two things only, routers and switches. Okay, so for this the activity here in this case, when the packet travels from one end to another end, just requirement is transmission of data, nothing else. Okay, so when it travel from one node to another node, we need not worry about whether the person purchased the ticket or our package or all those things. Not a concept, or not a thing related to the router. In between node, that is the transport entity. The transport entity is nothing but router. In between node need not worry about the ticket and all those kind of things. Okay, so it simply performs transport transmission alone. Okay, so that's why you need to worry about only one thing, routing. When it gets the packet will be forwarded to the appropriate outlet. Okay, so here the ticket and all those, the remaining layer is not required for the in-between nodes. Okay, so the sender end system, one full protocol suite to be executed, and the receiver end system, one full protocol suite to be executed, but in between nodes, routers, switches, just worry about routing alone. Okay, so that is a thing. We can easily map this example with a real internet protocol suite. Okay, can you understand? Layered architecture example.
Yes, ma'am.
Okay, so with that we move on to the internet protocol suite. Internet protocol suite is also known as TCP/IP. Technically, it is named as TCP/IP, but it's a protocol suite for internet, so that it is known as Internet Protocol Suite. Okay, so why it is named as TCP/IP? Okay, because you can give some other name, Internet Protocol, or you can give a protocol suite for internet. You can give different name, but why it is TCP/IP? There is a reason behind this. Okay, the reason behind this name, but before that, I will give you one extra input, because you need not stick on with the computer network alone. We have a award called Turing Award. How many of you know about this Turing Award?
Yes, ma'am.
Anybody knows about this
Ma'am,
Turing?
yes, ma'am.
This is
Ma'am,
a
it is like Nobel Prize in computer science kind of
good,
equivalent.
very good. Third year, you are very bright. Okay, so for computing, okay, I started to write school of computing. Okay, let it be for computing field. There is a prestigious award called the Turing Award. Okay, this is equivalent to the worth of the Turing Award is equivalent to the Nobel Prize Award. Okay, but this is only for the experts or innovator in computer domain alone. Okay, so now the TCP is designed by the scientist. Okay, that person got this Turing Award. Okay, I think in the year 80s or 90s, I don't know exact year. You just explore more. The designer of TCP/IP got this prestigious award. Okay, so now you know what is the real change made by that scientist. Okay, I'll tell you the name of the scientist also. He got that prestigious award. And you explore more about the Turing Awards also. Not only computing domain, the person who are working in cryptography, the person who are working in network security, the person who are working in cloud are getting this award. Okay, I think you know the famous cryptographic algorithm. What is a famous cryptographic algorithm? There are so many algorithms are available, but even though if you are not aware of cryptography, you
RSA.
RSA, reversed Shamir and Adalman. Okay,
Yes,
reversed
something.
Shamir Adalman, when they were the student at Stanford University in 1977, they invented the algorithm crypto first. It's popular not only because of its strength. It's popular because it's a very first publicly cryptographic algorithm or asymmetric cryptography algorithm. He got that prestigious award in the year 80s or 90s, I think. I don't know the exact year. Similarly, Diffie-Hellman is also one person who got Diffie and Hellman. Diffie from Stanford University, Hellman from Oracle Corporation. They got this award in 2016, but they invented this protocol in the year 1976. Okay, let's stop the history, because if it goes, then I may be deviated from the topic. Let me get into this TCP/IP protocol. TCP/IP, it's a famous protocol. The Turing Award, not only for famous. Whenever there is a whenever the particular protocol or whenever the particular technique or whenever particular algorithm, if it really makes a tremendous social impact, then this award will be given for those the innovators. Okay, so the TCP/IP designer got this award because it is successful. Okay, so why it is successful? Because of the internet. Okay, so it's a suitable protocol for internet. If you want to access the internet, we need that protocol, TCP/IP. Okay, I said why it is TCP/IP. The reason is that normally whenever we talk about networking, we have two different type of communication. Okay, slightly deviating. Again, I write it out. One is known as connection oriented communication. I touch upon it so that I can understand the real meaning behind the TCP and IP. Okay, connection oriented and connectionless. Okay, there are two type of communication. One is connection oriented communication, another one is connectionless communication. Connection oriented communication, the best example I can say it, landline telephonic communication. Okay, so whenever you dial the number, what is actually happening? It try to connect with the destination. Once it is connected, once after the person pick the telephone, then you can make the communication. So connection to be set up first, and then we can transmit and receive the data, then the connection to be closed. During that period, the entire connection is a dedicated connection between the two end system. Okay, two end telephones. So that type of communication is known as connection oriented communication. That should be the dedicated connection between the sender and receiver. Connection or transport to be established first, and then the data to be transmitted and received. That is connection oriented. Okay, but what is another way of communicating with the destination? What is another way of sending and receiving the information to the person who is located in a different remote place? Postal system. In the connection list, for example, the person can write a letter and can put it in the post box. Then the letter travel from one end to another and it reach a destination. Then the person can open it. Okay, that is a simple means of networking, connectionless networking. Okay, so connection oriented and connectionless, both are available in internet. I will tell you. In connection oriented, it provides connection oriented transport facility, connectionless network facility. Okay, so in one layer, in this particular layer, it provides connectionless service. Connectionless service. Okay, in this layer, it provides connection oriented service. Connection oriented service. Okay, so connection oriented transport protocol is, we have only one connection oriented transport protocol, that is TCP, transmission control protocol. We have connectionless IP protocol. We have only one connectionless IP protocol, which is IP, internet protocol. Okay, so internet is a combination of connection oriented transport, connectionless network. Connection oriented transport service, connectionless network service. Initially seems to be tough to understand, because ultimately we are doing networking. The packet should move from source to destination, but you are saying that in one layer it is connection oriented, in one layer connectionless. What it really means, okay, I will tell you. But the packing is something, the success of internet is only because of the combination of these two. Okay, connection oriented end to end communication, connectionless network communication. Okay, I'll show you with this graph, with this slide itself. See, what is a connection oriented end to end protocol? See here, in the from source to destination, it makes a connection. It makes connection between source to destination. Don't think in terms of wired connection and wireless connection. Okay, so here there will be the process, sender process, and here there is a process called receiver process. Sender process communicates with the receiver process in live. Okay, that is connection oriented transport. Okay, Whenever the packet moves from one end to another end, it passes through different nodes. Okay. So here in this area, it is connectionless. Okay. So connectionless network service, connection oriented transport service. Okay. So that's why it is known as TCP IP protocol. Even though we have various protocol in the application layer, link layer, physical layer, but we have taken two protocol combined together that forms that itself named as an internet protocol. So TCP IP, connection oriented transport service. It provides connection oriented transport service, connectionless network service. Okay. So I have given the name, but anyhow, it's a 5-layer protocol. It has 5 layers. Okay. So if you start from top to bottom, the first layer is the application layer. It's a layer 1. Okay. Let me talk about this layer, application layer. Okay. Internet application, it's not limited now. We have so many application, but I have shown only 3 application: FTP, SMTP and HTTP. But these are not application. Normally application layer, in this layer, application protocols are implemented, executed. Okay. So what is application protocol? What is the purpose of networking? To perform something. Okay. For example, you might be interested to transfer the file from one end to another end. Okay. What is the application? File transfer is application. Okay. Let me write down the application. For file transfer application, file transfer is a service. Okay. Application. Okay. If you want to transfer the file from one end to another end, we need application layer protocol. That protocol is known as FTP. FTP provides a rule set for transferring the file from one end to another end. Okay. So in this application protocol, in this application layer, this is a layer 5, 5th layer, top layer, layer 5. Okay. So there is a protocol named as FTP protocol. What is the purpose of this FTP protocol? FTP protocol allows the user to transmit the file from one end to another end. Okay. And another dominating application, internet application is mail, Gmail or Yahoo Mail or whatever may be the mail. Okay. If you want to access the mail, if you want to send and receive the mail, then you need the protocol called simple mail transfer protocol. Okay. If you take simple mail transfer protocol, our user requirement is sending and receiving the mail. Okay. Mail process. For that the mail, I need SMTP protocol. SMTP protocol is a rule set for this service. FTP protocol is a rule set for this service. Okay. So similarly, if you want to access the World Wide Web server, because web server is playing a role here, you have to access www.sasas.edu, nitt.edu, whatever it may be. You have to use the protocol called hypertext transfer protocol. Okay. But not limited with that, we have so many application protocols are evolving every day, and new protocols are evolving. Okay. So what is the purpose of this protocol? These protocols specifies the application, okay, specify the service or implement the service. Okay. So whenever we talk about FTP protocol, how the file to be transmitted from one location to another location, what should be the content of the file, what is the header in the file, what type of data in the file can be the text file or it may be the image file, what should be the type of the content in the file, and how to divide the file content into small pieces. All those things are the part of the application. Okay. So application layer directly communicate with the user communicates directly with the application. Okay. So that is a top level layer. Okay. So many, this itself is a protocol, set of protocol. This itself is a protocol suite. We have so many protocols: FTP, SMTP, HTTP. All these are protocols under application layer. Normally these application layer protocols are implemented by using high level languages. FTP, if you want to implement FTP standard, FTP receiver, then you have to use high level language, Python, Java or any high level language. Application programs are written in high level language. Okay. Application programs are user programs, not system program. It runs on the user space. I think you are learning OS parallelly, so it runs on user space, user program. Okay. So that is a top level. Okay. So if you want to do the project in the application protocol, then you can use application layer services. You can take any one of the high level languages. You can implement. We have SMTP protocol. You can think in terms of personalized mail transfer protocol. You can think in terms of personalized video content distribution. Okay. For that you are supposed to write only 2 programs: sender side program, receiver side program, to be implemented in the high level language. Okay. As the application programmer, You need not worry about the underlying transport, how the data to be transmitted from one end to another end, whether the underlying medium is a physical medium or wireless medium, and all those things you need not worry about that. Okay, so this is the first layer 5. Then the next layer 4. Okay, so the layer 4 is a transport layer. Layer 4 normally implemented as a system program, OS program or system program. Okay, it will be the syscall, system calls. Okay, what is the purpose of the transport layer? In transport layer, I have taken only TCP, but we have another options also UDP, but the predominant transport service is by TCP. We have two different type of protocol under the transport layer, only two options. Okay, in application layer we have so many options, not limited. Okay, you can also define within your own application service. Okay, but the underlying transport, if you take any host or end system, it has a system call for two different type of protocol. One is transmission control protocol and another option is a user datagram protocol. Okay, so what is the purpose of the transport protocol? The transport protocol is responsible for making end-to-end connection. Okay, so what is that end-to-end connection? Let me get into that, because I need one small page here. In the transport layer, we need to make end-to-end connection and link-to-link connection. You need to know the difference between end-to-end and link-to-link. Okay, so let me take, this is host A. Okay, this is one system, one end of the system, and we have another destination computer, host B. Okay, so ultimately the host A and host B wants to transmit and receive the data. That's it. Okay, so to transmit and receive the data, definitely it should be connected with a network. Okay, so this one should also be connected with the network. What is actually internet? Internet is made up of routers and switches. I may have the routers like this. Let me take, I have 5 routers. Simple example here. Some routers are there and these routers are connected with the links. Okay, this is entirely known as network, sub network. Okay, so I have a set of routers and switch. Okay, so this is a router and this is nothing but transmission links. Okay, so altogether this is known as subnet. Okay, not network, subnet. Okay, so if you want to transmit the data, the computer, to be connected with the network. Okay, the computer to be connected with the network. The computer to be connected with the network. How? This one to be connected with a gateway router. Let it be this is connected with this gateway router. Similarly, this computer should also be connected with the network. So this is connected with this gateway router. Okay, assume like this. Okay, let me take one more router here. This is connected with this router and this is connected with this router. And this router is a gateway router for this host, and this router is a gateway router for this host. What do you mean by gateway router? Whenever the packet is transmitted, okay, the packet get into the first router. Okay, the first entry point is this router. Okay, the packet received by this router. Let me name it as, this is router 1. Okay, let it be this is router 2 and this is 3, and here it is router 4 and router 5, router 6. Okay, so now when the router receives the packet, can you able to follow me, students?
Yes, ma'am.
When the packet reaches this router, when the router receives the packet, the packet includes the destination address. Okay, and the packet to be forwarded to any one of the link. Okay, let me take it out. For a link alone, I am going to use. Okay, so the packet travel like this. Okay, now it reaches this router. This router decides outlink. Okay, whether this link or this link. Okay, we have 3 links. Which link to be used, to be decided by the router. Okay, that is based on the concept called forwarding table. I'll talk about that. The forwarding table decides the outlink to be used. Okay, the forwarding table decides the outlink to be used based on the destination address in the packet. Okay, so the packet is having destination address. Just it will open the packet. Based on the packet destination address, it will choose this link or this or this. Okay, assume the router decides this outlink. Okay, so it injected the packet onto this link. Then the packet moves here, travels like this. Okay, now this router receives the packet. After receiving the packet, it decides the outlink. Now here the packet travel. So now the packet travel in the same direction. Let me take. So here the packet travel here. Okay. So the packet travels here. This router receives the packet. Router 5 receives the packet and decides the outlink. Okay, let me take this outlink and then packet travels like this. Okay. So this is the travel or route of the packet I have shown in the green color. Okay, the travel of the packet I have shown in the green color. Okay, see, we have here two type of connectivity. One is known as end-to-end action, end-to-end layers. Another one is known as link-to-link layer. We have two things to be considered: link-to-link layer and end-to-end layer. Okay, so the end-to-end layer, this host, okay, wants to transmit something to this host. Okay, so in this host, there should be the layer called transport layer. The transport layer provides some services. The first service is that here the transport entity of this host create a connection with the transport entity of this host. Okay, first of all, establishing the connection. Okay, establishing the connection, virtual connection from A to B. Okay, so that is a first component of the transport entity. So the transport entity is responsible for creating the connection. Okay, so after that, first one, connection establishment, connection to be established. Okay. Okay, so connection to be established first. Then what is its next step? Once after establishing the connection, the packet to be transmitted. Okay, the packet to be transmitted from one end to another end. But in the transport connectivity, if you talk about transport, okay, so here whenever we transmit the packet from this node to this node, okay, we need to worry about two important things. Okay, one is there is a possibility of error. Okay, and another thing is that this computer may be the mainframe computer or supercomputer, and this may be the laptop computer. Okay, all the devices are not homogeneous, the devices are heterogeneous, the computers are connected with the heterogeneous devices. Okay, assume this may be the fast sender and this may be the slow receiver. Okay, the reverse thing can also happen. Okay, the sender may be the slow sender, receiver may be the fast receiver. Okay, see, if this host injecting the data at the rate of 1 Mbps, okay, the host B should receive the data at the rate of 1 Mbps, then only it can receive the data. Okay, if the receiver is not capable of receiving the data at that speed, then what will happen? Sender transmits the data at the rate of 1 Mbps, but receiver receives the data in terms of 1 kbps. If it is so, what will happen? The receiver will receive only 1 kbps, the remaining thing will be discarded. Okay, there is a possibility of loss of data. Similarly, the fast sender, slow sender, fast receiver. Sender is capable of transmitting the data at the rate of 1 kbps, but receiver capable of receiving the data at the rate of 1 mbps, because the receiver is a supercomputer. Okay, now there is a problem of delay in the receiver side. Okay, so we have to regulate the flow rate between the sender and receiver. Okay, so for that it includes some algorithms. Okay, it includes algorithm. Those algorithms are named as flow control algorithm. Okay, so the second service of the transport layer is that flow control algorithms. Okay, why? Okay, so we have the flow control procedures. So this is a flow control algorithm. So flow control algorithm regulate the flow of data between the sender and receiver. Regulate the flow of data between the sender and receiver. Okay, fast sender, slow receiver. Here the thing to be considered is only sender and receiver. Okay, fast sender, so slow receiver to be regulated. Okay, what is the third step? Third step,
Ma'am, is it possible by creating buffer only, ma'am?
yes, yes. The transport layer, the transmission control protocol, receiver will create the buffer. Sender also creates a buffer. It maintains a window. It decides which packet to be transmitted, which segment to be transmitted, how much segment to be transmitted. All those things are the part of the transport layer. It's based on the buffer. Good.
Okay, ma'am. Thank you.
So connection establishment. Second part is flow control, regulating the flow of data. Regulating the flow of data not in between router, regulating the flow of data between the sender and receiver alone. Okay, so that's why it is known as end to end. You need not worry about in between link. In between link may be a narrow link, okay, or a broader link, whatever it may be. Don't worry about that. Okay, we are thinking about the sender and receiver alone. Sender is a end system, receiver is a end system. Okay, so that's why the transport protocol is known as end to end protocol. Okay, so second service is a flow control. And third important service provided by the transport layer is that, okay, it's erasing again and again, we are talking about transport versus network. Okay, transport versus network layer. Okay, so first connection establishment, second point is flow control, and third point is that transport layer is responsible for transport services. Transport layer is responsible for error control. Okay, so whenever if we transmit the data, we need accurate delivery. Okay, so for example, the sender has transmitted 10101110. Okay, it should be received by the receiver as 10101110. Okay, so this is a reliability, accurate reception of the data. The data to be received as it is sent by the sender. Okay, as it is, not with a noise, but it's not directly connected, it passes through the entire network. This network is made up of wired and wireless link. The wired and wireless link, if you take wired link, coaxial cable or fiber cable, whatever it may be, it is not reliable. What do you mean not reliable? There is no guarantee of inverted bit in the pattern. Okay, some of the bit may be inverted because there is a possibility of noise. Okay, minimum if you take fiber channel, there is a possibility of noise in the fiber channel. It is not reliable. Only 90% or 95% reliable. Okay, what do you mean by 90% reliable? If you transmit hundreds of bits, definitely 10% of bits might be inverted. Okay, so if you take wireless, there is a possibility of so many noise and interference. Okay, so the channel, the underlying medium transmits the data with the induced noise. Okay, but here in the transport layer entity, receiver transport layer entity should be capable of detecting the error and correcting the error. Okay, we have error detection algorithm and error correction algorithm part of the transport layer. That is based on coding theory. Okay, we have Reed Solomon code, convolutional code, binary code, CRC, Hamming code. So different type of error correction algorithms are available with a different reliability rate. Okay, but this is also a task of the TCP, transport protocol. Transport protocol is responsible for establishing the connection between the sender and receiver. It creates the connection between the sender and receiver, and it is responsible for regulating the flow of data between the sender and receiver, flow control, and it it is responsible for controlling the error. Controlling the error means detecting and correcting the error. Now, controlling the error doesn't mean that reduce